Hello my dear children, once again welcome to our physics class. Hope you all are fine over there. So we were doing revision of our previous portions. Today also I am here with the revision of our second chapter, Force and Laws of Motion. In the previous sessions we had discussed about the first chapter, Motion, and today we are going to discuss our second chapter, Force and Laws of Motion. So quickly we can revise the important concepts of this chapter. Along with this, you must practice the numericals very much. You must practice all the numericals that I have given you during my video classes. It's very important. So the first concept that we encounter in the second chapter is force. And you have been studying about force in your lower classes. What do you mean by force? A force is a push or a pull. And what are the effects of force? You know that whenever you apply some force on an object, that object will change its shape, or sometimes it may change its size, it may change its velocity, or it may change its direction of motion of the object. And you are familiar with numerous examples of the effects of force. Okay, and two types of forces are balanced force and unbalanced force. And what do you mean by balanced force? Here you can consider a table. Okay, this is a table and a book is lying on this table. On both ends of the book, weight hanger of 50 gram is suspended. Here also weight hanger of 50 gram is suspended. Here you can see on either sides of the table, two weight hangers of 50 gram each have been suspended. So the forces acting on both sides of the book will be same, and both the forces are acting in opposite direction, isn't it? And such type of forces is known as balanced force. As a result of this balanced force, the book is not moving. The book is at rest. The two weight hangers of 50 gram each has not brought any effect on the position of the book. The book does not change its position. So from this we can understand one thing: balanced force does not bring about any effect on an object. Balanced force does not bring any effect on an object. But at the same time, suppose on this side I have suspended a weight hanger of 100 gram. Okay, and on this side 50 gram weight hanger has been suspended. Now what happens? Yeah, it's very familiar. The book will move towards the direction of greater force. So here 100 gram will produce more force than the force produced by the 50 gram. So the book will move towards the direction of greater force. So here you can see a change in the position of the book, right? And these two forces are not equal. They are unequal. So these forces which acts in which are unequal in magnitude, at the same time which acts in the opposite direction, are known as unbalanced force. So only unbalanced force can bring some change or some effect on an object. Only unbalanced force can bring about a change or any effect on an object. So it's an important concept regarding balanced and unbalanced forces. Balanced force does not bring any effect on the object, but unbalanced force will bring some effect on the object. Next, we discussed about the Newton's laws of motion. So Newton has put forward 3 laws of motion. What is the first law? First law states that a body remains in its state of rest or of uniform motion if unless an external unbalanced force acts on it. Okay, so what is the force? What is the law? First law states that a body remains in its state of rest or of uniform motion unless an external unbalanced force acts on it. So this is the first law. So just imagine a book is lying on the table. That book will remain there as long as we apply some force on it. The moment we apply some force on the book, it will move from its position. Okay, so that book has changed its position, or that book will continue to remain in that position until we apply some external force on that book. The moment we apply external force on the book, it changes its state of rest. Okay, so that is Newton's law of motion, first law of motion. A body remains in its state, tends to remain in its state of rest or of uniform motion unless an external unbalanced force acts on it. And this natural tendency of an object to remain in its state of rest or of uniform motion is known as inertia. Okay, so what is inertia? Newton's first law leads to the concept of inertia. So what is inertia? Inertia is the natural tendency of an object to remain in its state of rest or of uniform motion. Okay, and inertia is related to mass. Massive objects have more inertia. Okay, if we consider a 5 rupee coin and a 1 rupee coin, a 5 rupee coin will have more inertia. If you consider a truck and a train, train will have more inertia. If you consider a rabbit or an elephant, elephant has more inertia. So that is the relation between inertia and mass. So that's all about the first law. Numerous applications of first law can be cited from the daily life situations. And we have explained all those situations clearly in our video class. I hope you remember all those. So anyway, I will cite some of them. See, whenever you travel by bus, you are familiar with this experience. Whenever the bus is stopped suddenly, you will have a tendency to move forward. This is due to inertia of motion. Whenever the bus is started suddenly, there is a tendency to move backward. So this is due to inertia of rest. Okay, when the branches of tree are shaken vigorously, leaves will fall down. When the carpet is beaten with a stick, dust comes out of it. So all can be considered as examples of inertia, and it is advisable to tie the luggages in your bus with a rope. It is due to inertia. Then whenever the car takes a sharp turn, you will have a tendency to be thrown out to one side of the car. So to prevent that, it is advisable to wear safety belts. Okay, seat belts. All these examples can be related to Newton's first law of motion. Then second law. Newton's second law states that the rate of change of momentum is directly proportional to the force applied, external force applied on an object. So rate of change of momentum. What do you mean by momentum? So Newton's second law leads to the concept of momentum. So momentum is denoted by P, and momentum is calculated using the expression mass into velocity. Unit of momentum is kilogram meter per second square. Sorry, second, only second. Okay, unit of momentum is kilogram meter per second, not square. So this is the unit of momentum, kilogram meter per second, and momentum is a vector quantity. What is momentum? Momentum is the tendency of a moving object, or it is the ability of a moving object to produce an impact on another object, and it is defined as the product of mass and velocity. Okay, and so let's discuss about the mathematical expression of Newton's second law. F is equal to ma. That is the expression for Newton's second law. This is very important expression, and several examples can be cited from our daily life situations based on Newton's second law. You might have seen a cricketer draws his hands backwards while catching a ball. This is due to decrease the rate of change of momentum, which in turn decreases the force. because rate of change of momentum is proportional to force. So if rate of change of momentum decreases, external force applied also decreases. So the force exerted by the ball on his palm decreases, and which does not exert much pain on the palm. Similarly, you might have seen during high jump or long jump, the athletes are jumping to a cushion bed or sand bed. So this is also to decrease the rate of change of momentum, which in turn decreases the force exerted by the ground on the body of the athletes. So they will not experience much pain. Okay, so that's all about Newton's second law. Then Newton's third law. This is a very famous law. To every action, there is an equal and opposite reaction. See, consider there are two objects A and B. Suppose A exerts a force on B, and that force can be denoted by FAB, force exerted by A on B. So if A exerts a force on B, then B in turn exerts a force on A, which is denoted by FBA. That means for every action, so FAB considered as an action, for every action there is an equal and opposite reaction. So FBA is the reaction force. Okay, FBA is the reaction force. So we can write FAB is equal to FBA, but at the same time it is opposite in direction, so a negative sign appears here. So if A exerts a force of 10 Newton on B, then B in turn exerts a force of 10 Newton on A, but in opposite direction. So this is Newton's third law. Then what is law of conservation of momentum? Law of conservation of momentum states that in the absence of external forces, the total momentum of a system remains constant. In the absence of external forces, the total momentum remains constant. The law of conservation of momentum states that in the absence of external forces, the total momentum remains constant. That means the total momentum before collision, the total momentum before collision is equal to total momentum after collision. So this is law of conservation of momentum. Suppose total momentum before collision is 10, then total momentum after collision is also 10. Okay, see, if we consider one example, suppose two objects are there, A and B, and this A initially moving with a velocity UA and B is initially moving with a velocity UB, and A is moving faster than B. So after some time A will collide with B. So collision happens, A will collide with B, and after collision A and B moves with different velocity. So let VA be the velocity of A and let VB be the velocity of B. Okay, so here let MA is the mass of A, let MB be the mass of B. So before collision and after collision, mass of the object does not change. So after collision also, mass of the object will remain MA and MB respectively, but the velocity will change. Initially A and B are moving with velocities UA and UB, but finally their velocities are VA and VB. So what is the total momentum before collision? Total momentum before collision is MAUA, that is momentum of A, plus MBUB, that is momentum of B. So this is total momentum before collision, MAUA plus MBUB, equal to total momentum after collision. So here what is total momentum after collision? MA into VA, which is the final momentum of A, plus MB into VB, which is the final momentum of B. So this is law of conservation of momentum. Again, you can expect numericals from this law of conservation of momentum. So this area is very important. Go through the numericals of this chapter. Also, especially focus on the numericals of this concept. Okay, children. So with this, I am concluding my session. You have notes of the topic and YouTube video have been already uploaded during the video lessons. So please go through your notes, and there will be a small review test based on this session. So please attend the test and post me the answers quickly. So we will meet in the next session. Till then, take care all of you. Stay home, stay safe, keep learning for your exams. Okay, prepare well for your exams. Thank you.